This lesson is on comparing linear and nonlinear functions. The graph of a linear function shows a constant rate of change. A nonlinear function does not have a constant rate of change, so the graph is not a line. So first, we're going to identify functions from tables. So we want to determine, is this table linear or is it nonlinear? So to determine this, we need to find what the slope is, or what the constant rate of change is. So let's first look at the x values and see if we can find a pattern. From one value to the next, from 3 to 6, I am adding 3. From 6 to 9, I am also adding 3. From 9 to 12, I am also adding 3. Now let's check, so we can see the top, the x values are constant. Now let's look at our y values and determine if they are constant. From 40 to 32, we are subtracting 8. From 32 to 24, again, we are subtracting 8. And then from 24 to 16, we are also subtracting 8. So because x increases by 3 and y decreases by 8 every time, we know that the rate of change is constant. That way we know this is a function. This is linear. So it is linear because x increases by 3 and y decreases by 8. That way we know we have a constant rate of change. All right, let's look at the next problem. To get from 1 to 3, we are adding 2. From 3 to 5, we are adding 2. From 5 to 8, we are also adding 2. So we see that for the x value, it is constant. Now from the y values, 2 to 11, we are adding 9. From 11 to 33, we're adding 22. And from 33 to 88, we're adding 55. So we see that there's a constant rate of change with our x values, but there's not a constant rate of change with our y values. So this means this function here is nonlinear. Linear. And that's because the y values, y increases by different amounts. Okay, so that's how we can tell if a table is linear or nonlinear, because they both have to be at a constant rate, both the x value and the y value. And if either one of them or both of them is not constant, then that means that it is nonlinear, and it would not make a straight line. Now we can look at identifying functions from graphs. So when we're looking at graphs, we can just actually look at the problem and determine if it's linear or nonlinear. Remember, the word linear means it makes a straight line. Nonlinear means it does not make a straight line. So just by looking at this first graph here, we see that it is curved. So because it is curved, we know that it is nonlinear. It's a nonlinear function. And that is because the graph is not a line. Okay. And then when we look at the next example, we see that it is a straight line. It is actually a horizontal line. So we know this one is linear because it is a line. Because the graph is a line. So that one we can just look at the graph and determine if it is or isn't. All right. Now let's look at the next example. So this is identifying a function if it is nonlinear or linear from an equation. So a reminder that linear equations can all be written in slope-intercept form. Y equals mx plus b. This is how we determine if a line is linear or not, because it follows the slope-intercept form. So what we're going to do in each of these problems is we're going to determine whether they represent or which one is a nonlinear equation, because there is one of them here that does not go into the form y equals mx plus b. So let's look at each of these problems. Looking at A, y equals mx plus b. This one does go into that form, just the slope happens to be 0, and the b happens to be 4.7. So this is linear, that's not our answer. Looking at B, y equals mx plus b, we can see that our m can be replaced with pi, and that our b is actually 0 because there's nothing being added on. So since this can be written in the form y equals mx plus b, that is a linear function, so it's not b. Looking at C, y equals mx plus b. So this one, since we have x on the bottom, there's no way to bring it to the top. So this one actually is not in the form y equals mx plus b. So this one is nonlinear because we can't write it in that form. And we'll just check the last one. So we want to make sure it can be in the form y equals mx plus b. In this case, we can distribute the 4, because it'd be y equals 4 times x is 4x. 4 times negative 1 is a negative 4. So yes, we can see that this one can be written in the form y equals mx plus b. So we know that one is linear. So our answer to this question is C. Y equals 4 over x is nonlinear, or is a nonlinear function. And that is because it is not in the form y equals mx plus b. And last one, let's look at this real-life application. So it says accountant A earns simple interest. Accountant B earns compound interest. The table shows the balances for 5 years. Graph the data and compare the graphs. So, given the information on the left in this table, we can see that the first column is year. So it shows year 0 all the way to year 5. So first, let's look at accountant A and determine if theirs is linear or not. I see every year it's going up by 1 year every time, plus 1, plus 1, plus 1, plus 1. And now let's look at what happens every year with their balance. You can see that we are increasing by 10, increasing by 10, by 10, by 10, and by 10. So we know that accountant A has a constant rate of change of $10. So theirs is constantly increasing by $10 every year. So we know that accountant A is a linear equation. Okay, now let's look at accountant B. So this one, they go up by 10, and then even the next one that goes up by 11. So even right there, we can stop and see that we know it's not going to be constant. Because if it goes up by 10, up by 11, up by, looks like a little over 12, 12.10, we see that it's changing every time. Every year, it's going up by a different amount. So constant B does not have a constant rate of change. Because their amount is different every year. And so they are, and so it is nonlinear. Okay, and then I already graphed it to the right, and we can tell how these would be graphed. So you can see accountant A is in blue, and we can see that it's going up by 10 every time. It has a constant slope. It's going up 10 over 1, up 10 over 1, up 10 over 1. It's constant. Whereas accountant B, we can see that it is getting more and more and more. It's changing its rate of change every time. Every single year, it's changing, which is why it is this curved line, which shows that it is a nonlinear function.